Hello, today we're going to take a look at angle of elevation and angle of depression, and specifically how we utilize them in trig problems. Let's do it. So the first thing I want to do is define what an angle of elevation or an angle of depression is. They are the angles that your line of sight or line of light makes with a horizon. So if the problem mentions the angle of elevation, then the angle of elevation is the angle the line of sight makes with a line parallel to the horizon. So that right there would be the angle of elevation. The angle of depression also is in relation to the horizon. But if it says angle of depression, then the horizon line will be drawn above your line of sight or line of light. So that's your angle of depression. It's the angle made with the horizon from above. But what I want you to notice is that the angle of depression is the same thing as the angle of elevation, because if I draw my parallel line down here at the ground, alternate interior angles tell me that those two are the same. Same thing here. If I've got my angle of elevation, but I draw my parallel line of horizon above it, alternate interior angles tell me that those two are the same. So let's say your problem says you've got a person, you've got a tree, and your person wants to look at the very tip top of the tree. So the first thing I'm going to do is I'm going to draw a line from the person's eye line to the top of the tree. And then I'm also going to draw a line from the person's eye line parallel with the horizon. And then I'm going to connect those two to make a triangle. Okay, so one thing to know about these trig word problems, if they give you something like a person, a tree, a building, anything that's standing straight up on the ground, they are giving you a right angle. And anytime you have a right angle, you know that SOHCAHTOA and the Pythagorean theorem apply. If these are unfamiliar to you, go take a look at this video and then come on back. But let's say in this word problem, they let you know that the distance from the ground to the top of the tree is 14 feet, and they let you know that the person's eye line is 5 feet off the ground. And then let's say they tell you that the angle of elevation is 28 degrees. Okay, so there's our line of sight. There's our horizon. Angle of elevation is the angle between those two. That's 28 degrees. And let's say the problem finishes by saying, how far is the person from the tree? So we're going to call that X. And I redrew my stylish tree to make it a little more clear that there's a consistent distance from the tree. All right, so now we have to set this up. All right, our X in relation to our angle, right? We're looking to say, is it an opposite, a hypotenuse, or an adjacent? Well, we know the hypotenuse is opposite the 90-degree angle. We know that the side opposite the 28 is over there, which leaves this guy being the adjacent. So we're looking at either a cosine or a tangent. And then we say, well, where do we have information? Well, we don't know our hypotenuse, but we do know that this full length is 14 and this much of it is 5, leaving us with our opposite side being 14 minus 5, or 9. And now we have an opposite and an adjacent, which leaves us with the TOA syllable. So we're going to set that up. T, tangent. Well, tangent is of an angle. We have our angle. Tangent of 28 equals opposite over adjacent. And now we have an equation we can solve. So we're going to multiply our x to both sides. We're going to divide both sides by tangent of 28. That's 1 unit. That's a number when you punch it into your calculator. So don't think you've got to divide by 28 and by tangent. That's a single thing. And now I'm ready to put that into my calculator. I notice my degree marks. So I want to make sure my calculator is in degree mode. And I find that my fellow is 16.93 feet away from the tree. Okay, angle of depression. So let's say I have a lighthouse and its light is directly in the center of the lighthouse and it is shining on a manhole cover that is 40 feet away from the center of the lighthouse. And let's say I know that my lighthouse all the way up to the light is 15 feet tall, and I would like to know the angle of depression that my lighthouse makes with that manhole cover. All right, angle of depression. That is the angle my line of light makes with the horizon above it. But for my purposes, I would rather work with this one. So I'm going to use alternate interior angles to put that angle down there. And then I'm going to complete my triangle by dropping a line straight down to the center of the lighthouse. And I'm going to remember that lighthouses, trees, buildings, people give me right angles in my problem. So now I can use SOHCAHTOA to finish up. So I ask myself, in relation to my angle, what's my 15? What's my 40? Well, again, my hypotenuse is there. So that makes my 15 my opposite. So that's tangent or sine. Makes my 40 my adjacent. Once again, I'm using tangent. So I set it up as follows. Tangent, well, this time my angle measure is my variable. So tangent of x equals opposite over adjacent, 15 over 40. All right, I now need to solve for x, and that's where I use my tan inverse key, which says the angle whose tangent is. So tan inverse of 15 over 40 tells me that x is the angle whose tangent is 15 over 40, and that's what we had up here. So again, I'm going to make sure I'm in degree mode. I'm going to put it in my calculator, and I find that my angle of depression or elevation is approximately 20.56 degrees. All right, that's angle of elevation and angle of depression. Take a look at some of these other videos on trig. There's another one here with some word problems you can practice with. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.